Okay. We have our axis of rotation, and now our task really is to, well, we've tried to figure out, well, now we've actually placed it at the origin Earth, but when I go all the way back to the beginning and I start playing with the model of my solar system, it's not rotating, is it? No, it's not. Huh? Right, yes, we didn't apply it to that particular condition. So what we have to do is go back and get the information that's going to allow us to assign this to that planet instead. Okay, so what I've done, what I've simulated for you, is looking at something in the abstract before you make it more complicated by rotators and all this other stuff. Okay, so we built it in the abstract. Now we're going to modify it to the more complex and more physically accurate condition. So we can start to look at that sphere, right? So that sphere is, a geometry that's based off, or actually rotated from the original Earth, right? The Earth origin point is something that we can extract using the same kind of rotator. Okay, so if we were to possibly take this same rotator and copy and paste it and replace it with the Earth's origin point instead, then what we get on our second planet is a selectable center point for the new Earth.
Where did you plug into the point?
I overrode the same connection. So here, when I copy and paste the rotate, it borrows all the same connections that it originally had. So if I want to rotate a different geometry instead, all I have to do is replace the geometry that I'm rotating. So if I want the point, or the Earth origin, I can move the Earth origin by rotating it the same way that I've rotated the Earth itself. So by doing that, I've sort of eliminated the idea that if I was to take that point and add it to the rotation, technically that works because there's a point there. I don't know if you can see it on that screen, but there's a point there. And technically that works, but then I still have that list of a point and a sphere that I would then have to break apart in order to select just the point. So rather than doing that, I figured it's easier to just copy paste and plug the point in, and I could do it that way. Okay, so we have the Earth origin that I set up as a wireless connection. The other thing I'm going to set up is the new Earth center point. So I can yank this one back here a little bit. I'll try to keep it as clean as possible. I'll just leave it there. I'll pull these all back though. I'm going to do the same thing by passing a point through, except under params here, rather than, did I use a point for the Earth origin? I did. So I'm going to grab a point again, and I'll plug this in so that it is the Earth origin again. Right click it, and so here I'm going to call it N for new Earth center. So I copy and paste that, plug it in. So you've seen this before. You've seen where you've had the rotated whatever point, and then you've had the param point, and then param point. This last one is the one that I make wireless. Let's see. Like that. New Earth center, new Earth center. If I take the Earth center and replace it now with the Earth origin, then that gives me a new location for this entire definition. Right, so all I have to do is carry the Earth center down, put it right next to Earth origin. Right, so now these two are going back to their respective places. And if I just replace it, it moves that whole construct, right? All this information that we've done over here gets instantly moved to the new origin point. So now let me zoom out real fast so you can see the real power of this. I'm going to get into like a perspective view, sort of. If I go all the way back to my Earth position around the sun for each day of the year, now you can see at the origin it's synced up. But as I slide it around, it's pretty cool stuff, right? Oh, gee, thanks, guys. All right, so I'm going to pause here for a second and get you guys caught up to this before I move on to explaining a little bit more about it. So I just had a couple of questions come up that were kind of the same question. So I imagine since the first two people I spoke to had exactly the same question, there are a number of you that have the same question as well. And it was, why are we doing this wire display configuration, right? The wire display, it's kind of laborious, right? You already have the information, right? So it is a point, right? It rotated the point, and so the output is a point. Why don't I just plug that point into where it's supposed to go? So the reason I do this is because if I just plugged it into where it was supposed to go, and right now it's really simple, okay? Right now it's not all that big a deal. But if I just plug it into where it's supposed to go, if I made this wireless, I wouldn't be able to see where it came from, okay? So if and let me just do it for you real fast, I guess. You know, I could just plug this in, and it's going to do exactly the same thing in the absence of all of these. Okay, so right now it's a singular connection. But when I have more compound definitions, and for instance, when I start actually rotating geometry around this axis of rotation, then we need to be able to control what the visibility is between the different ideas that we're writing, the different statements. Okay, so for instance, and I'm just going to copy and paste this a whole bunch of times. So if I have an idea and I build it down here, another one, I build it down there, and then I have to take this idea a little bit further, but I also have to reference this over there as well. And then I have to do the same thing down here. All this information gets a little bit crazy. So the reason I do this is so that when I have, I'll go back here, when I have this here, like that, I can go to all of the different ideas that I've generated, wherever they are in space, and I can read what their origin is. So for instance, if I'm referencing and building this one off of the Earth's center point, then that's great. I already know because I have all of my anchor information back here in the top left corner, and I'll talk about that a little bit later on when our stuff does get more complex. I have all my anchor information back here. It says new Earth center. I know that I'm going to work with Earth origins. I have a bunch of those going out. I have an Earth center point. I have a bunch of those going out. So all this stuff is going to get more complex. And this allows us to kind of float around the different ideas and see what it's being built on. It's kind of like, if any of you guys have done any kind of computer programming before? Anybody? One person, a little bit. A little bit. Okay, so in computer programming, let me see if I can just pull up an example. Okay, so this is a simple example of a code, right? So this is, I don't know, because I'm not really a computer programmer. What I do know, what I do know is that this is a simple hello button method. I know that it's version 1.0. I know that the author was John Doe and that his email is doe.j@example.com. How do I know that? Because he wrote a comment that tells me that. Right? I know that I am to use this J-frame line. I am to use it for support for new components when it's finished, or before it's finished, right? So it says use the J-frame type until support for T whatever new component is finished. I don't know, it looks like it's unfinished. But anyway, I know that he's telling me things. So the reason I am inputting all of this seemingly extraneous information is because when someone who has no idea what this definition is gets into it, you know, you guys, maybe if you miss a class, you can read it. Particularly, it's not all that important right now, but I'm giving this method to you now so you can practice it. Because later on, you're going to need it. I guarantee you, you're going to need it. Because, you know, this kind of stuff, right there, all this stuff over here, it's going to get crazy. We're not going to get probably that crazy, but like, see this right here? This is a good example, right? I'll bet that a lot of this information on the left is being referenced with all this on the right. It probably is. You can't see it, but it is. And I'll bet you they're using these pass-throughs, these params, these empty data parameters, in order to pass that information through in a seamless and clean way. Does that answer any questions about that? All right, so you'll see instances of when and how I do that. I do want to throw another cool one out there for you, in case you guys are really into it and you like separating these different ideas. I do want to introduce right now the jump thing. I don't know what you call it, jump component. Jump is really important. Wes, you're going to take this one. So jump allows us to put a little connector here from one idea to the next. So I can put my jump all the way back at my base like that. So this is all the information that generates the housing for the solar system. I can pull this one out to a different idea, like right here. Right now they're pretty close, but let's say I had a bunch that moved out this way. The cool thing about jump is when I look at this information, I can go to my jump and it pulls me to where it leads to.
Whoa.
Right? Yeah. I know, it's super cool. So, and then you can jump back to where that information came from. These tools are there because definitions get big and they are hard to follow. Okay? So that was very long-winded, I recognize. Very long-winded. But it's important you understand what it's for.
The jump is just for like
Yep, just connected from one to the other. It just brings you from one place to the next.
I can't jump.
You can't jump? Double click it.
Double click.